So the next topic is derivatives, limits and the derivatives. Derivative is rate of change of one variable with respect to another variable. And the definition of derivative is given as this. We will explain this in detail. For example, when x changes from a to a plus h, the change is a plus h minus a, so the change is this h. So we discuss it in detail. For example, if your revenue function is, if you produce something and your revenue function is x times 75 minus 3x, when you produce 9 gadgets, so your revenue will be 9 times 75 minus 3x, and when you produce 12 it will increase from this 9 to 12, so your revenue will be like this. And if you want to know that what is the change in revenue, so r of 12 minus r of 9 will give you the change in revenue. For example, if when you sell 10 bottles of water, you get 50 rupee, $50, right? And for 10 bottles, your revenue is $50. When you produce or sales 12 bottles, your revenue increased to $60. So what is the change in your revenue? The change in revenue is revenue of producing 12 bottles minus revenue of producing or selling 10 bottles, which is revenue for 12 bottles we are saying is 60, revenue for 10 bottles is 50, so the change in revenue is 10. So similarly here change in revenue is 36, revenue of 12 bottles minus revenue of 9, so it is 36. We substitute 12 and 9 in this formula respectively. The revenue formula is given like this. What is the average rate of change in revenue? So the average rate will be counted as revenue was from 9, we increased it to 12 minus 9, that was the change in revenue, and average change will be increase minus the old one. All right, so like here revenue from 12 to 9 and 12 minus 9, that is average change in revenue. So we increase from 9 units to 12, so change within these two numbers is measured by this. Now if I say that we are saying that we are producing x bottles, like here we are producing x bottles, so in that case we will say that here you can see that if I write same thing in a function form, it will become like x plus x is 9, from 9 we increased it 3, so we write h as 3 minus r of x, where x is 9, h is 3, so x plus h is 12, which is here given, right? Over for average change we will subtract 12 minus 9. So this is the definition for average rate of change. I hope you understood. So divided by h. Now this h is 3. This h is 3. If we decrease this h sufficiently small, or instantaneous change, to measure the instantaneous change, we make this h, which is initially, now in the previous slide it was 3, we say that this h is very small, we put the limit and we say that this h is approaching 0, it is that small, so it will become x plus h minus f of x over h. So this is the definition of derivative. We denote derivative by f dash. So here you can see that this is the definition of derivative limit h goes to 0, f of, you can denote it by a or f. So the instantaneous rate of change at x equals to a is given by this definition. Whatever x equals to, whatever x is, you can substitute it here. I wrote it in general form, that limit h goes to 0, and basic definition. As I said, we denote it by f dash. Sometimes we denote it df by dx. So there are different notations. So this is called the definition of derivative. So finding the derivative, there are certain steps. For example, if you are given a function f of x equals to, let's say, x square, to find the derivative, the very first step is, the step one is we write f of x as f of x plus h. Wherever you see x, you replace it by x plus h. So this will become x plus h whole square. Next step is we take their difference, f of x plus h minus f of x. So it will become f of x plus h square minus x square. Third step is take their quotient with h. So we take their quotient with h. So it will become like this. Fourth step, we apply limit h goes to 0, f of x plus h, f of x over h, limit h goes to 0. If I open the square, it will become like this. This x square will cancel out with this x square, and when you substitute the limit, you will get 2x. So that is the derivative of the function. For example, if you have this function, so we write this f of x. First of all, we write this f of x in f of x plus h form. Wherever we have x, we replace it with x plus h. We replace it with x plus h. We solve this, open the square, we get this function. Then we take their difference, f of x plus h minus f of x. When we take their difference here, it will become this. This will cancel out with this, minus 3x plus 3x will cancel out with this. You will get these three terms like this. Then we take their quotient with h. This h, this h, this h will come out, and it will cancel out with this denominator, and we will get this function. So when you apply the limit, you will get the required derivative.